Hello and welcome back to Little More Learning. This is the second video of Foundational Mathematics under Data Science, and today we will be dealing with matrix. So, matrix is like a rectangular array of numbers, symbols, or expressions arranged in rows and columns. It is like a powerful mathematical tool that you can use to represent data, perform transformations, and solve equations in linear algebra. Now, when it comes to notation, a matrix is written as A, that is the name of the matrix, equals A11, A12, A21, and A22. So what actually this is? So this is AI of J. Here I represents the row index and J represents the column index. So firstly, let us understand this using this example. Like for 1, what will be the index of 1? Let us name it as A, row number 1 and column number 1. So these are the rows, like row 1 and row 2. This is column 1 and column 2. Now for 2, it will be row number 1, column number 2. That is 1, 2. It is A. Okay. Now for 3, it will be row number 2, column number 1. A21. Similarly for 4, it will be like this. Then we have different types of matrices. The first one that we have is a row matrix. How come it is a row? Like all the elements in this are represented in one row. So this is a row matrix. Then column matrix. All the elements are in a column. Like this way. Then comes a square matrix, where number of rows is equals to number of columns. Also, a matrix is represented as A n cross M, where A is the matrix, N is the number of rows, and M is the number of columns. So, square matrix is a matrix where N equals M, that is, number of rows is equal to number of columns. Example could be like this. There are 2 rows and 2 columns. Then is a zero matrix. The matrix where all the elements are 0 is a zero matrix. So let's say we have a matrix A named, and this is the square matrix and also a zero matrix. Next is identity matrix. That is basically a square matrix with ones on the diagonal and zeros elsewhere. So let's take its example. I, diagonal 1, else elements are 0. Then we have a diagonal matrix. Diagonal matrix is basically the matrix where all non-diagonal elements are 0. So let's take the example here. Like we have 7, 8 and 9 on the diagonal. Rest all the elements of the matrix will be 0. Next is matrix representation. So in data science, matrices are used to store data sets, perform transformations on them, and solve problems related to that data set. So here we have a data set with n rows of samples and m columns of features, and is to be represented as n cross m. So now we will understand how we can represent this data set in form of a n cross m matrix. So let's say we name the data set matrix as A, and we have column names as height, weight, and age. So the columns are basically features and the rows will be sample values. So here we can fill sample values like this. Any random values we can fill into it. And age we can fill. So this completes our data set with samples as row and features as columns. Now is the time to understand the basic properties of matrices. Firstly, shape. A matrix with n rows and m columns has the shape of n cross m. Suppose we have a matrix 1, 2, 3, 4 and 5. So this matrix has a shape of 1 into 5. Or if we take a 2D matrix, like 1, 2, 3, 4, this has a shape of 2 cross 2. That's how it works. Then is equality of matrices. A matrix A is equal to matrix B when they have the same dimensions and corresponding elements are equal. Suppose we have a matrix A that is 1, 2, 3, 4 and a matrix B that is also 1, 2, 3, 4. So the dimensions are same. Our first condition is fulfilled. And now if we check their corresponding elements, they are also same. So these two matrices are equal. That is A is equal to B. If any of the corresponding element would be different, suppose there is 4 and instead of 4 there would be 5. So they would be, A would not be equal to matrix B. Now let's understand some special matrices. Firstly is the symmetric matrix. A matrix A is symmetric if the transpose of that matrix is equal to the original matrix. Then we have upper and lower triangular matrices. Upper triangular matrix is that all elements below the diagonal are 0. Now if we take an example of this, suppose we have a matrix A. So how could be an upper triangle matrix? Let's see. 1, 2, 3, 4, 5, 6. Below the diagonal, all the elements are 0. Is an upper triangle. And if we take for lower triangle, above the matrix, all the elements would be 0. Like we take 1, 2, 3, 4, 5, 6. So these elements are 0. So this is a lower triangular matrix and this is a upper triangular matrix. Then we have sparse matrix, a matrix with a significant number of 0 elements. Like majority of the elements in this matrix are 0. Suppose we have these values. So the majority of elements in this matrix are 0. So this is a sparse matrix. Next we have matrix operations. Matrix operations are like the core of linear algebra and are used extensively in data science and machine learning. So we will be covering some basic operations that we can perform on matrices. Firstly is matrix addition or subtraction. Both works in a similar way. If we consider like this or we consider like this, the methodology to solve this will remain same. So let's take a simple example. When we have a matrix like this and a matrix this. Now, two matrices can be added or subtracted if they have the same dimension. So let's check the first condition, 2 cross 2, 2 cross 2. The dimensions are same. The result is a new matrix where each element is the sum of corresponding elements. So let's see how it will become A plus B. Okay. The resultant is C. Now, 1, the corresponding element to 1 is 5 plus 5. Then 2 and 6. And 3 and 7. Then 4 and 8. So the resultant matrix of A plus B will be 6, 8, 10 and 12. That's how you perform subtraction also. If we had to perform subtraction over this, then instead of adding these corresponding element, we would have subtracted them. And let's say it is C dash and 1 minus 5 would be minus 4. It would again be minus 4. All the elements would be minus 4. Then we have scalar multiplication. Simply, it is, let's say, like this. And we will take A to be the same matrix. And here the value of K would be 2. So the scalar quantity will be multiplied with each element of the matrix. So the result would be 2, 4, 6 and 8. Next, we have matrix multiplication. Matrix multiplication is not element-wise. It involves dot products of rows and columns. Let's say two matrices A and B can be multiplied if the number of columns in A equals the number of rows in B. Okay, so this should be equal, then only matrices can be multiplied with each other. Now, let's say we have two matrices 1, 3, 4. So how matrix multiplication is performed? This element is firstly multiplied with these and then this. Now let's understand what actually is happening here. So A cross B would be 1.5 plus 2.7, then 1.6 plus 2.8. Next 3.5 plus 4.7, then 3.6 plus 4.8. This is what actually happening in matrix multiplication. The first element of the row is multiplied with the first column. The second element in the row is multiplied with the second column. Then the same thing happens with the next rows. So the output will be 19, 22, 43 and 50. Then comes up transpose of a matrix. The transpose of a matrix A is denoted as AT and is obtained by swapping rows and columns. Simply, so if A is I of j, in transpose it will be A j of I. So if there is a matrix like this, so the transpose of this matrix will be, rows are converted into columns in simpler way. Then we have element-wise multiplication in matrices. In element-wise multiplication, the corresponding elements of two matrices are multiplied, and this is different from matrix multiplication. So this is the formula that you can just learn to solve element-wise multiplication problems in matrices. So how it is performed, let's take an example, then you will understand better. We have two matrices. Again, they are similar. The dimensions are same. So C equals 1, 5, 2, 6, 3.7, 4.8. Instead of multiplying the entire row with the entire column, we are just multiplying 1 to 5 and 2 to 6, 3 to 7 and 4 to 8. So the output of this would be 5, 12, 21 and 32. Now, last operation that we have for matrix is matrix division. Matrix division is not directly defined but can be interpreted as multiplying by the inverse of a matrix. So for example, if we have AX equal B, it involves calculating X, that is A inverse B, only if inverse of matrix A exists. So that's it for today's video. In the next video, we will look at determinants, eigenvalues, eigenvectors, and explore matrix division also. So that's it for today. Thank you for watching the video. And do subscribe to the channel and like the video. And don't forget to follow us on other social media platforms also. And see you in the next video. Till then, happy learning.